Welcome to the second SWAT4HCLS talk, where we will update some of the projects that have been going on in the hackathon, SWAT4HCLS hackathon that we ran on Friday, January 15 and Tuesday, January 19. I am honored to have François Belot here. I hope I pronounce your name right, but hello, François. Can you maybe introduce yourself to the group?
Yes, I work now in Quebec in the Arnold lab, which is a bioinformatic lab in Quebec, Canada. Originally, I've got interested in life science and linked data since I started Bio2RDF many years ago. Now, we're looking to new ways to do data integration, and I took the occasion to explore some concepts about having JSON-LD into Elasticsearch. So I started a small proof of concept, which is the Reactome to the JSON-LD project.
Thank you. And okay, I will give you the full floor, and so you can start.
So this project is about Reactome and linked data and Elasticsearch, and we will glue everything together using the Siren Investigate technology, which is a commercial product with a free open edition, which we will be using. The initial goal 4 days ago was, how can I create a Biomart-like user interface? Biomart was very popular 10 years ago to create Mart around different life science data set. At the moment, only very few Biomarts still alive. There is the one from Ensemble, AGNC. There used to be one for Reactome, and it's not available anymore. So could we create a Biomart-like experience for Reactome connected to CHEBI, Uniprot and the GO database, all connected to using URIs because we're a linked data group. So this was the initial project, but now this is what it was made. At the beginning, I was expecting to use CHEBI, Uniprot, Reactome, and gene ontology, but finally I added the intact and the very small reside database just to explore. A very important idea of this project is to fetch data from live REST services, because the REST services are so much more popular than Sparkle endpoints. They are stable, they are well maintained. So one of the important hypotheses, could we extract and transform the results from the data obtained from a REST JSON services to RDF and store it into Elasticsearch? That's the first part. That's the ETL part of the project. The second one would be, how can we explore these data sets? And this is where we will be using a fork from the Kibana project, which was open source from Elasticsearch. It's the Siren Data Investigate project, for which there is a free community edition. So all the data at the left were transformed into JSON, into triples, and stored back into the Siren Investigate. With 6 small programs, I was able to transform 1,500,000 documents from 6 different data sources. So this was the initial relational model I was proposing of 4 linked data dataset. And this is how it is now in the product of Siren Investigate. So Siren Investigate has a layer of relational, which can be used to connect non-relational into Elasticsearch. So there is a plugin within Siren Investigate that makes Elasticsearch a relational database. And this is how we describe at very high level the relationship between different indexes. So how we did that? So this was the initial project, let's say a recipe. We added the 2 resid and intact data sets, so we finally did 6. Everything was done in Python. I used Python to request the API and import the data into Elasticsearch. Something I didn't meant to, but was very powerful and very useful, I do the conversion of JSON to JSON-LD within the ElasticSearch. I'm using ElasticSearch cluster, so I could take advantage of those 4-node cluster powers to do very fast data transformation. And finally, everything is exported to our Siren Investigate instance in the cloud using Elastic DOM. Then we do the Siren Investigate work, which consists of creating visualization, combining things, and we will see that later more in detail. So this is a very simple script, but this is how easy I was able to fetch the WSDL services for CHEBI, which is an old service returning XML, and then transform those XML into Python dictionary, do some fixing, and then loading into Elasticsearch. So after writing this script, running it for, I think, 5 or 6 hours, not to be too hard on the WSDL services, I was able to get the all 170,000 molecule in CHEBI into in XML, loaded into Elasticsearch. All those scripts I use are available on this GitHub place. Then once the data is loaded, this is where I was able to use the pipeline of Elasticsearch, which is very declarative. It's a way to do data transformation. So it's the Elasticsearch last version ETL with a graph user interface. And it's very efficient and certainly very fast, because instead of transforming a document at a time, you have the all nodes cluster working for you. So it was simple. And I think it's going to be a very good tool to do the usual ETL work we need to do when we are doing transformation to get something into RDF format. Now, this is the magic of this project. The Kettle Group has designed many years ago the JSON-LD definition of a representation of an RDF triples graph into JSON. So with very simple modification, in fact, these are the modification we do. You see there is only 3 attributes which are necessary to be added to a JSON object. So it becomes a kind of RDF. And here you have an example of one document directly extracted from the Elasticsearch, and you see the returning triples coming from, it's a CHEBI document. So for each of those data sets, I verified that my JSON format was compatible with this. So this is the way eventually, not in this project, but eventually we could produce RDF from the 1,500,000 documents I just loaded into Elasticsearch. Now the Siren investigation visualization tool. So once the data is all up into Elasticsearch and move to the Siren Investigate Elasticsearch server, we had to build a visualization. So first we create visualization, and it's all graphical. We adapt the parameters, and then we gather visualization together into a dashboard. The second very important thing is this is how we created the relational model. So we had 6 different indexes, and just by connecting properties of each of those indexes, we were able to create relational. And those relations are used to navigate the graph. So it's the relation layer over the Elasticsearch index, which is very simple and easy to use. A very important thing here is the relation I use are all based on URIs. So I created for each of those indices a URI attribute to connect, for example, CHEBI and Uniprot and Reactome. And of course, the URI are used respect the identifier.org standard. So what the user of Biomart like was, so this is the result product. So first we have the slice and dicing data set. This was the main feature of Biomart. Selecting column, filtering thing, and using facets. So this is something out of the box from Kibana Siren Investigate platform. The next one is a full text search over all our data source. So I put on the left the famous NCBI and EBI, global text search over their website. So in matter of a couple of days, we have created the same kind of global user experience over Reactome, CHEBI, GO, Uniprot, and NTAC for very few efforts. So it's very easy using Elasticsearch and to aggregate all those indexes into a global and create a unified full text search environment. So what we see here is we have the different types, and here is the namespace. So the data source where this information comes from, and this is about exogenous. So we have found that there were a couple of hundred, I don't know the number here, but there are 46 results from exogenous coming from those 6 data sources we have treated and loaded into Elasticsearch. So let's say that this is the global text search over the graph. The next thing is the relational thing. So Reactome is composed of pathway, which contain reaction, and reaction are connected to physical entities, and physical entities are connected to external resource like Uniprot and EBI and CHEBI. So this is the model we have here, which is the pathway, and then the reaction, and then the entity, and finally we have the protein, and here a molecule from CHEBI. So if I do a search into reaction, then I will go directly to the pathway containing those reaction and the physical entity containing those same reaction. So this is a great and very useful functionality that the Siren Investigate have added over Elasticsearch index. Something very useful, and this is what the Kibana project was about, is create a dashboard. So we can create dashboard very visual just by designing a visualization and gathering them. So it's a dashboard, it's interactive, it's facet browsing, and it was done in those kind of dashboard are done in minutes using the framework. And this was the most exciting part. I hope to get there. In fact, I did. Here we have the CHEBI molecule involved in the process, which is exogenous according to Reactome pathway. So this is a graph representation, the kind of graph representation we have with Cytoscape or other tool, but it's there for free within the Siren Investigate environment. It's based on there is a Gremlin server in the back end to make this possible. And it's very intuitive, and I think that in life science we depend a lot of those kind of data visualization tool, and now we have one which is included over Elasticsearch indexes. So this is the plus. I didn't expect it to go up there, but of course there was not that kind of tool within Biomart. Now there is one into this environment. Conclusion. So my initial hypothesis is we should try to exploit the REST-JSON API and to create RDF. And it was fast and easy. And this is maybe the most persistent data source we're going to have in the next years. Then converting JSON to JSON-LD is very simple and efficient. And in fact, using Elasticsearch pipeline, I was surprised how fast I could transform hundreds of thousands of documents within the cluster. Of course, from this experiment, I can say that Elasticsearch is a good container to store JSON-LD. In fact, it's a great container to store JSON. But because we're linked data enthusiasts, I think that exploring the use of Elasticsearch to store RDF is interesting. So we get to, with Elasticsearch, we get URI, which are dereferencable. This is out of the box because this is Elasticsearch as REST API. We have a truly fast text search and query language, which is not Sparkle. And this is maybe a big minus over this project. And I think this is very important. We have efficiency of storage, and we can use, we can store terabytes of data within terabytes of indexes, but it's very compact and the access is very fast. I would like to make a link with the HDT project, which is, of course, another way to do the same kind of objective. Finally, we were using only the Siren Investigate Community Edition. Now we show that we can browse with Facet. We can build a dashboard, which is very visual. We were able to query a relational data model, which is a truly original innovation from Siren. And finally, and this was surprising to me, I was able to explore the knowledge graph using their performing graph browser. Finally, I think this experiment, during the hackathon, I was able to confirm that there is a way to store RDF in Elasticsearch and do useful things. What's next? In fact, this project was done over the infrastructure and the expertise we have developed within the CHEBI Science project. So this is our main project using Elasticsearch at the AD Lab. And I take the opportunity to participate to the hackathon and the SWAT4HCLS event to invite for collaboration, because our goal is to build a life science data source for the community based on Elasticsearch, and we have a partnership with Siren Investigate. Finally, I would like to thank my colleague at the lab. My PI is Dr. Arnaud Dra, Michael and Regis. Regis is a PhD student working on the CHEBI Science project. And I would also like to thank the Siren team who helped me to manage in a very short time the tools, the very powerful tool their company have made available. So thank you very much for your time. I hope it wasn't too long. I hope it's inspiring and it's a beginning of a new adventure. Any question? Yes, Andrea, I stopped my screen, my share screen.
Can you hear me?
Yeah.
Yeah. Thank you very much, Francois. It was very inspiring and interesting. And I like how you set out some steps forward. I would like to use the opportunity to say that we've set up a Discord server for SWAT4HCLS, which I will share the links. We'll share a link shortly in the documentation, and I'm looking forward to collaborations there. Thank you for your time.
I typed something wrong.
No, I want to say I'm looking forward to next step, and we hope to see this being presented at the SWAT4HCLS conferences in December.
In fact, I hope our PhD students get to there, and I will try, because I have a proof of concept now to have the CHEBI Science project integrate the link data thing. I didn't mention it because it's too early, but I think we have the brain power into your community. My whole goal is to do Sparkle query over that kind of stuff. And the linked data fragment is a very nice approach. And Ruben is designed that. It's not very performing, but it wasn't done with I think the idea of running Sparkle over different API, different source is the way to go. This is for me, it's the kind of growl of linked data, and we're not there yet. And I think that if we can define proper API and proper software, and if we can, for example, we will be able to show in, you know what I'm going to do in the next month? I'm going to put all this data into Virtuoso. So we will be able to do the Sparkle over that ready to use SOAP or REST API datasets to show how useful is it. Yeah. And, I think the idea of transforming everything into RDF, it's too costly and it's not going to win. We need to find another way.
We are looking forward to the next steps, either on the Discord server or on other platforms. Again, I would like to thank you for giving the time and sharing what you and your group have been doing during the hackathon before and beyond. And I'm looking forward to next steps. Thank you for your time.
Thank you very much. Bye-bye.